Hi everyone, welcome back to Remote Sensing Pro. If you are new here, this channel is all about breaking down remote sensing and GIS for beginners and researchers. In our last tutorial, we learned how to extract and visualize different Landsat bands and build both true color and false color composites in Python. Today, we're picking up right where we left off, using those same bands to calculate and explore NDVI, the most widely used vegetation index. So here's a quick reminder of how we set up our bands. First, we use Colab to grab the file path and rasterio to read each band into Python. Today we'll use the red and near-infrared bands, band 4 and 5 for NDVI analysis. So I'm going to remove the rest of the bands since we're not using them today, and we'll just focus on the bands we want to use. Awesome. Here we've got the band 4 and band 5, and they correspond to red and near infrared. So before we start coding, let's quickly talk about what NDVI is and why it's used everywhere in remote sensing. NDVI stands for Normalized Difference Vegetation Index. It's a simple formula that uses the near-infrared and red bands from satellite images. Plants, for example, reflect a lot of near-infrared light and absorb red light. So by comparing the two, NDVI highlights where vegetation is healthy, stressed, or absent. So high NDVI values mean lots of green, healthy plants, and low or negative values mean bare soil, water, or urban areas. It's super popular because it's easy to calculate and tells you a lot about the landscape. Now let's calculate NDVI. First, we need to import NumPy as NP. To calculate NDVI, we need to convert both red and near-infrared arrays to float 32. That way, Python won't accidentally use integer division, which would give the wrong result or round everything off. So the red, go to red.astype, convert to float 32. We'll do so for near-infrared, near.astype. We'll do float 32 again. Okay, so we have the red and the near-infrared arrays converted to float 32. Now let's write the formula for NDVI. The NDVI formula is just the near-infrared minus red divided by near-infrared plus red. Divided by near-infrared plus red. Okay, I need to put these in brackets. Okay, so we've got the NDVI formula right here. Good. So before we run this code, one other thing we need to do is to ensure that all the 0 pixels are set to NaN. To do these, I need to use NumPy's where. Do NDVI, go to NumPy.where. So wherever we have near infrared plus red, that is equal to 0, we need to do what? Do NumPy.set none, alright, within the NDVI pixels. Okay, let's have a look at this. We have red set to float 32, same as near infrared, and we have the formula for NDVI, and then we've just set all pixels. The denominator is 0. We set them to none. Alright. Good. Okay, so this looks good. Although we have this warning here that usually pops up once in a while. To remove this warning, you can easily come here to set with NumPy.error state. Anything that has divide, just ignore it, right? And then what else is that's invalid? Yes, invalid, ignore. Okay, I think this should get things done for us. I just set it for this equation right here. So we say NumPy error state divide equal to ignore and invalid equal to ignore. Awesome. So we just removed the error warning that we got earlier. Let's plot our NDVI map. We do that by importing Matplotlib. .pyplot as plt plt.figure. So I want to use these to control the fig size. Can do, I usually like 4x4 most times, but let's do 6x6 today. And I want to do plt.imshow. I want to show the NDVI. And we usually do CMap, right? What color are we doing today? Let's think about something new. Okay, let's do red, yellow, and green. So this is going to give us the color scale of red, yellow, and green for the NDVI values. Okay. And because we want to display the values, we'll need to add a color bar to that. plt.colorbar for the NDVI. And then we'll label it. Do we need to label it? Yeah, let's label it. Label it to NDVI. We'll do plt.show. One more thing is to not confuse Python with these two NDVI. So I will set this to NDVI map and bring it down here. So we're plotting these for the NDVI map and now the calculation that we just did here. So this is going to plot this NDVI and we're going to use the color map for this. This way, whenever we change this, we'll be able to run this code over and over again. Oh, okay. Label code 2. Good, this looks good. Let's do the blue, brown, and green BRBG. Okay, I think this looks better. Okay, from my own view, I think this is better than the first one. The green area to be, I don't know, is this green or let's say teal? Green color to be the forest areas, and I would just say vegetation to make it easy. Then we have the white where we have water. And we also have the urban, like the built up area that is not quite showing pretty well here. And we're going to see that in our next steps. Then we have this yellow or orange that shows sediment concentrated areas, as well as this part, you can see the sediment concentration. Okay, let's first of all compare this NDVI to the true color and see if the results gonna like come out pretty well, like in terms of comparison, if you can see the difference looking at the true color and looking at the NDVI. To compare NDVI to true color, we need to grab our true color image right here. So this is our true color that we plotted in the last tutorial. So just grab this code right here and put it down here. Okay, so here we have the 2% linear stretch that we did before, and we applied the stretch to this image. And now we want to use the same plot to compare this side by side. To do this side by side, so let's keep it to 6 and 6, or maybe 6 and 10, or maybe 10 and 5, I mean. Okay, so we have the first true color stretch image, and we want to get this plot right here. You remove this show, so we have just one show, plt.show, and remove this. Now we have the fixed size as 10 by 5. We have our first plot and we have our second plot. Okay, so we're going to use subplot, plt.subplot. So we do row, columns, and the first. So for the second one, we do the same, plt.subplot. We're going to assign this 1, 2, 2. So this is the second plot. Okay, that should work. So we have the two images side by side. This is the true color image, and this is the NDVI we just plotted above. Here you can see the NDVI ranges from -1 to 1. And looking at this, you can actually see we have more forested areas here. And you can see the sediment concentration right here, and it pops up here as well, as you can see right inside here. However, there are some features you can't see pretty well because this is a very large area, and that's why we need to zoom in for more details. To do that, we need to set our rows and columns. We're going to do rows start and rows end, and we do column start and column end as well. So for the rows, I will do, let's see if we can capture this area and also this area to see the difference between these two. So we'll do maybe 1000 start and 4000 to end it. And then for the column, 1000 will be too far. So let's do 2000 for the column to start it with 2000 and end with 4000. Okay. Row start and row end, row end, 1000 and 4000. We'll do so for column start and column end. This would do 2000 and 4000. Alright, now let's apply this selection to what we have here. I'm going to bring down our plot. We're going to apply the selection we have for each of the plots. So to do that, we just add just change these to column. Alright, and we'll do the same for the second one, our second plot. Okay, so we just applied this selection we've got here to the first plot, and we do the same for the second one. This is start. Alright, row start, row end, column start, column end. Okay, let me check this to ensure that we don't have any issues with spellings and all that. Alright, looks good. You can plot this. Great. Okay, when you look at this now, you realize that it's far better than this, right? Because this is kind of bigger. However, here we have a closer look at what the features look like. Here you can see these sediments concentration right here, the sediments in the water column, and we have the bare soil, because this is a coastal region, right? We have the bare soil, different color as well, and you can also see that the color bar also changed. Initially we have 1 to -1. Now we have -0.2 to 0.6. This is the bar for a specific location that we selected. And we still have the green areas as the vegetation. So I think this looks better than this one right here. Next is to save the NDVI map, just in case you want to use it for your presentation or anything else you want to use the map for. You will need to save the map and not just screenshot it, right? So to do that, first I think we need to add a title to these maps right here. We could do like PLT the title. Let's give it, the first one is true color. I'll do the second one, PLT the title. NDVI. Okay, this looks better. So we have the titles for each of the maps. Yeah, this looks better now. So once someone looks at it, the person sees that this is a true color image and this is your NDVI calculated from the true color or from the image itself. Now let's go ahead to save. To save your image, you need to just add one line of code before PLT does show. You do PLT the save figure. So to save the map, you need at least a path where you want the map to be saved. So I'll grab my own path. So I want to save mine right here. So I'm putting the R once more because I don't want to change the backslashes. And I want to save it as NDVI map.png. And I also want to set the DPI to 300. Then set the bbox inches as tight. Alright, this is done. So what DPI 300 means is that it sets the resolution to high quality, 300 dots per inch, and the bbox inches just removes extra white space around the save plot. So this keeps our image looking good. We're gonna see the result once it's exported. Okay, so the maps are plotted and also saved. Now let me go grab mine from the folder. And here comes our map. So once you finish saving, you can open it and you're going to see your amazing map right in front of you. Okay, and that's it for today. You've learned how to calculate and map NDVI from a Landsat image in Python. In our next video, we'll learn how to crop your image to your study area so your analysis is focused where you need it. Drop your questions and don't forget to like and subscribe if you found this helpful.